Hello, algebra students. Today we're going to be working with polynomials again, but instead of doing adding and subtracting like we did in the last lesson, we're going to be distributing, which involves some multiplication. And we will have some parts that will have exponents on our variables. So let's remember what we do when we have multiplication, same bases. So for instance, x to the third times x to the fifth, when I multiply those same bases, that we should add the exponent. So we'll get x to the eighth as our answer. So my first problem isn't even a distribution problem. It's just a multiplication. You did this already. This is not new. So we would multiply the 3 times the 2 to get a 6. And then for my x's, just like on the last screen, I had them in a different order, but x to the fifth and x to the third gives me x to the eighth. Then for my y's, I have a y squared over here. Don't forget that this y really has a y to the first power, so that'll be a y to the third. And then that one's done. There's nothing else to do there. Nothing else combines or goes together. That's as simplified as it gets. The second example is a distribution. So the 2x is going to be multiplied first times the 2x squared. So the 2 times 2, the coefficients give me 4. And then x squared times the x that's out here, x to the first, gives me x to the third. We've got our subtraction. And then 2x times 1 is just 2x. And then remember, these do not combine. They are not like terms because the exponents don't match. So that problem's just done. That's as much as I can do to simplify that. In this next example, both of these examples, in fact, I'm distributing a monomial, one term on the outside, to a trinomial on the inside. When I do this multiplication, 6y, remember that's 6y to the first, times 4y to the second would give me 24, and that'll be a y to the third, minus 6y times 9y would be 54, not just a regular y, right? We have y times y would be y squared, minus, there's no variable in this part, but we can still multiply the coefficients. So 6 times 7 is 42, and then we just carry that y along. In the second example, very similar, 3x times 2x squared would be 6x to the third. I didn't put the 1 on the x this time, but you know that it's there. Plus, 3 times 3 is 9, then we'll have an x squared, and 3x times 5 is 15x. And again, in both of these problems, the exponents don't match on the variables, so I can't combine anything else. I had a trinomial on the inside of the parentheses. I'm going to end up with a trinomial in my answer. In the first example here, I am distributing a negative number this time with my monomial, so that'll be a negative 12x to the fourth power, I've got a 1 right there, plus, right, this is a negative 3 on the outside, this is really a negative 1x. So when I multiply, that's going to give me a positive 3x squared. And this distribution would give me a negative, or subtracting 30x, right? Negative 3 times positive 10, negative 30. This time I've got x's and y's in one of the terms, which isn't a big deal after what we've done with all of our exponent unit. So 2x times x will be 2x squared. 2x times 3xy. Now, if I didn't have the y on there, I would just get 6x squared. That would match with what I have. However, when I do multiply that, I do have a y there, which means they don't match. If the variables don't match entirely, exactly the same, they don't match and you're done. Now, distributing just more stuff with variables and with exponents. I'm going to do this multiplication. The 2 is the only number, the only coefficient that I have. For my a's, I have an a squared times an a to the third, gives me a to the fifth, and the b squared is still there. Plus, 2 times 3 is going to be 6, A squared times A will be A cubed. B squared times B will be B cubed, right? We've got a 1 on both of those. Minus 2, the A squared doesn't change, but I've got a B squared times a B cubed gives me B to the 5th. And again, just because these all have A's and B's doesn't mean they all match. They're not like terms. They all have different exponents going on, so they don't match at all. And on this second problem, trying to throw in as many variables and exponents and negatives as we can. So with this distribution, -2 times a -3 is going to be a positive 6. X squared times x squared will be x to the 4th, and we have a y. -2 times a -4 is positive 8. X squared times x is x cubed. Y times y is y squared. Then the -2 times the 5 would be a -10. X squared, y to the 3rd, because we had a y squared inside the parentheses and a regular y on the outside. I hope that all made sense. It's just distribution, and we've done all that work with exponents already, so that shouldn't be a surprise. You have a worksheet today, and the answer key is in Schoology. We do not have a learning check today, a formative. We will have one on Wednesday that will cover all the material from Monday and Tuesday. So be looking forward to that. And if you need any help, let me know.